Hi, in this tutorial we're going to be revising factor theorem. So just as a reminder, what does the factor theorem say? Well, the factor theorem states that if for a given polynomial f of x, which could be a polynomial of degree 2, which could be a quadratic polynomial, or a polynomial of degree 3, which is a cubic polynomial, if f of a is equal to 0, then x minus a will be a factor of f of x. And if f of minus a is equal to 0, then x plus a is a factor of f of x. So we're going to be running through 3 different examples where we need to be able to apply the factor theorem to be able to factorize a cubic polynomial. So let's start off with example number 1. So example number 1 says factorize fully fx equals x cubed plus 7x squared minus x minus 7. So this is a cubic polynomial. It's also known as a polynomial of degree 3 because the highest power in this polynomial is 3. So it's known as a cubic polynomial. And we wish to factorize this cubic polynomial. In order for us to factorize this cubic polynomial, we need to be able to determine one of the factors to begin with. To determine one of the factors, we need to be able to look at the constant term, and we need to be able to find all the factors of the constant term. So our constant term is minus 7. So we need to ask ourselves, what are the factors of minus 7? Well, the factors of minus 7 are 1 and 7. And it's a prime number, so these are going to be the only 2 positive factors of 7. Now, since our constant term is negative, it means we will need to look at both the positive and negative values of 1 and 7. So I'm just going to indicate a plus or minus in front of both of these 2 values. So we're going to start off by looking at the smaller value. So positive 1 would probably be the best one to start with. And we're going to start off by substituting positive 1 into our polynomial. So we're going to start off by writing f of 1. So that means wherever we see an x, we will need to replace x with positive 1. So we'll have 1 cubed plus 7 lots of 1 squared, negative 1 minus 7. And all we now need to do is to evaluate this result. Well, 1 cubed is 1. 1 squared times 7 is 7, so 7 plus the 1 is 8. 8 minus 1 is 7, and 7 minus 7 is equal to 0. So we can say, well, f of 1 is equal to 0. Well, that's good news, because according to our factor theorem, it says if f of a is equal to 0, so in our case, f of 1 is equal to 0, then x minus a is a factor of f of x. So in our case, since f of 1 is equal to 0, we can say therefore x minus 1 is a factor of f of x. So we have now determined one of the factors. So one of the factors is x minus 1. Now we're going to use this factor to help us determine the remaining factors. So to do that, we're going to express this cubic polynomial in the following form. So we're going to say x cubed plus 7x squared minus x minus 7 will be equivalent to our given factor x minus 1. Now this factor that we've just determined is a linear factor. It's a linear factor because x is raised to the first power. It's x to the power 1. Now we need to ask ourselves, well, if I want to fully factorize this linear factor needs to be multiplied by some other factor that will give us a cubic polynomial. Well, a cubic polynomial has degree 3. We've currently got a linear polynomial which has degree 1. So it makes sense for us to multiply this linear polynomial by a polynomial of degree 2 to give us a polynomial of degree 3. So a polynomial of degree 2 is a quadratic polynomial, and a quadratic polynomial will be written in the form ax squared plus bx plus c. So our goal now is to determine the values for a, b and c. Now we can do that in two ways. We can either expand this entire result and then start comparing certain coefficients of certain powered terms, or we can take a small little shortcut, which is what I'm going to talk about here. So first thing is, let's have a look at the value for a. Now if I were to multiply out x with ax squared, I will get ax cube. That's a cubic term. Well, if you look on the left hand side, this is our cubic term. What's the coefficient of our x cubed term? Well, the coefficient of our x cubed term is 1. This is a 1x cube. So if ax cube will be identical to 1x cube, it makes sense that a is equal to 1. So we're just going to record it here by the side. We're going to say a is equal to 1. Similarly, if I were to multiply minus 1 with c, I get negative 1c, or negative c. That's the constant term. Well, on the left hand side, our constant term is minus 7. So we can say minus 7 is equal to minus c. Well, if minus 7 is equal to minus c, then it makes sense for c to be equal to 7. So we can say c is equal to 7. With our given values a and c, let's put those in. So we can now say that this is equal to x minus 1 multiplied by ax squared, where a is equal to 1. So that'll be x squared. Bx, we haven't yet determined what b is. However, we know what c is. C is equal to positive 7. Okay, so we now need to determine the value for b. Now this one's a little bit more trickier. It's not as simple as simply just multiplying one term in one bracket with the other term in the other bracket like we did above. So we're still going to do some multiplication, but we're going to multiply two particular terms. We're going to multiply x with bx. That gives us bx squared. So that's an x squared term. But I also can obtain an x squared term if I multiply these two terms. That gives me negative 1x squared. And if you were to expand the whole thing out, you will actually find that these are the only two x squared terms that we will obtain. So we're going to compare these x squared terms with the x squared term on the left hand side. Now, I might need to do a little bit of work on the side. So we're just going to do a little bit of work on the side over here. So we're going to say, well, on the left hand side we have 7x squared. So 7x squared is going to be equal to bx squared, which is the product of these two terms, and minus 1x squared, which is the product of those two terms. So we've got bx squared negative 1x squared. Now remember, we're only trying to determine the value for b. So what will b be so that I can obtain 7x squared? So just to make our life a little bit easy, let's just strike off the x squared terms as such. So we're left with 7 is equal to b minus 1. And this should be fairly straightforward. We can see that b in this case must be 8, since 8 minus 1 gives you 7. So we have now obtained the value for b. Sorry, that should be 8. Okay, well, now that we know the value for b, we can put that back in. So we can say x minus 1 multiplied by x squared plus 8x plus 7. So our cubic polynomial has been factorized into a linear factor, x minus 1, as well as a quadratic factor, x squared plus 8x plus 7. Now if we analyze this quadratic factor in more detail, we need to ask ourselves, is it possible to factorize this quadratic into two linear factors? And upon careful inspection, we need to say, well, yes, we can. Numbers that multiply together to give you 7 but add together to give you 8, in this case would be 1 and 7. So we can factorize this further, and we obtain x minus 1, x plus 7, and x plus 1. This is our final result. So given a polynomial fx equal to x cubed plus 7x squared minus x minus 7, it's now been fully factorized and written as a product of three linear factors. This method of obtaining the quadratic factor is known as comparing coefficients. This is not the only way. We can also use algebraic division to be able to find this quadratic factor, and then once you found your quadratic factor by algebraic division, you will just factorize it further by writing it as a product of two linear factors. So let's move on to example 2. So example 2, we've given a polynomial fx equals 2x cubed plus 3x squared minus 18x plus 8, and in this case we're told we want to use the factor theorem to show that x minus 2 is a factor of f of x, and also we wish to factorize fx completely. So in this case, for part A, we need to demonstrate that x minus 2 is a factor of f of x. So to show that x minus 2 is a factor of f of x, we need to substitute a value for x into our polynomial. So what is the value for x that we will substitute into our polynomial, given that we're told x minus 2 is a factor? Well, we will need to substitute positive 2. So given that x minus 2 is a factor, positive 2 will need to be substituted into our polynomial. So we'll start off by writing f of 2 is equal to that's great. If f of 2 is equal to 0, we are expecting 0 as an answer, since we're told it's a factor of f of x. So we'll simply conclude our answer by saying, therefore, x minus 2 is a factor of f of x. And it's important that we write this statement down all the time. Even though we're told it's a factor, but we need to demonstrate to the examiner that yes, we do get 0 when we do that substitution. And what does that 0 ultimately mean? That 0 means 0 remainder. if something is going to be a factor, it means it will divide into something exactly with 0 remainder. So we've got 0 remainder. Given that we've got 0 remainder, it must mean that x minus 2 is a factor of that polynomial. So that's part A completed. Let's move on to part B. Part B says to factorize fx completely. Well, now that we know that x minus 2 is a factor, we can now start to use our comparing coefficient technique, or we can go down the route of using algebraic division. So I'll continue with using comparing coefficients. So to do that, we're going to write down our polynomial on the left hand side. So we've got 2x cubed plus 3x squared minus 18x plus 8, and that's going to be equivalent to, well, our factor that we've determined, x minus 2. And remember, this is a linear factor. This linear factor has to be multiplied by a quadratic factor to give us a cubic. So a quadratic factor is written in the form ax squared plus bx plus c. So we now need to determine the values for a, b and c. So we'll work out the two that we know are simple. That's going to be a and c to begin with. So how do we work out the value for a? Well, multiplying these two terms gives me ax cubed, and here we're saying that should be equal to 2x cubed. So what must a be? Well, a must be equal to 2. So we can say x minus 2 multiplied by 2x squared. At the minute we don't know what b will be. That's going to come in the next step. But c we can do in a similar manner. So what do we multiply together? Well, c is a constant term in this quadratic factor, and minus 2 is a constant term in this linear factor. I can multiply these two constant terms together. That gives me negative 2c. And the constant term here is 8. So let's compare them. 8 is equal to minus 2c. Let's just jot that down. So 8 is equal to minus 2c. So in this case, we know that c must be equal to minus 4. So this is going to become 2x squared plus bx minus 4. So our next challenge is to work out the value for b. So x multiplied by bx gives me bx squared, and negative 2 multiplied by 2x squared gives me minus 4x squared. Now we're going to say that should be equal to 3x squared, which is the term on the left hand side. So let's ignore the x squareds, so strike them out. So we're left with 3 is equal to b minus 4, and guess what? B is equal to 7. So let's put that back in as well. So what do we end up with? We have x minus 2 multiplied by 2x squared, our b number, which is positive 7, so positive 7x minus 4. And that's our quadratic factor. And given that we now have our quadratic factor, our next challenge is to be able to factorize this quadratic factor further. So this is our cubic polynomial now fully factorized. Right, final example. Now this is a slightly more tricky one. Given that f of x is equal to 2x cubed plus kx squared, so straight away that tells me that we might need to work out what this value for k is, minus 4x minus 3. And we've given some information. It says given that x plus 3 is a factor of fx, we need to show that k is equal to 5. Then we need to factorize, and then we're going to solve. So let's start off with part A. So we'll do part A over here just on the side, since I might be running out of space. So for part A of this question, how do we show that k is equal to 5? Well, we go back to our factor theorem. If x plus 3 is a factor, then what value of x can we substitute into our polynomial? Well, we can substitute minus 3. So we can say f of minus 3 is equal to So let's evaluate each of these parts separately. Okay, well, this is what f of minus 3 is, but remember, we're told it's a factor. And what does it mean if x plus 3 is a factor? Well, it means x plus 3 will divide into this polynomial completely. And if something divides into another polynomial completely, it means there must be 0 remainder. So this will be equal to 0. Well, that's a nice equation for us to solve. And it was a show question, and this is sufficient proof to show that k must be equal to 5. So before we move into part B, just to summarize, we're told it's a factor, so we substitute minus 3. Since it's a factor, it means there's 0 remainder, hence we set up this equation, and hence we can calculate the unknown in this equation. So this means that we can take our value for 5, k is equal to 5, and substitute it back into our polynomial to have a complete polynomial. So for part B of the question, it would be a good idea to start off by writing fx is equal to 2x cubed plus 5x squared minus 4x minus 3. And now we wish to factorize, writing the polynomial. So we've got 2x cubed plus 5x squared minus 4x minus 3, and that's going to be equal to our factor that we have been told, and this factor will need to be multiplied by a quadratic factor, so same as before. So that's part B now fully completed. So for part C of the question, it says to solve fx is equal to 0. So f of x is our polynomial, which we have now fully factorized. So let's take our fully factorized polynomial and we're going to make that equal to 0. So now this is an equation. Let's solve this equation. So given that it's now fully factorized, we'll take each factor in turn to determine the values for x. So for the first one, x plus 3, if that's equal to 0, it means x must be equal to negative 3. If 2x plus 1 is equal to 0, it means x must be equal to negative 1 but divided by 2. And finally, if x minus 1 is equal to 0, then x is equal to positive 1. So these are our three solutions. In fact, these are also known as the roots of the polynomial. Okay, so as well as calling them solutions, they're also known as roots. Okay, and roots basically means where the graph will pass over the x-axis. So we can draw ourselves a little sketch, although the question is not asking for it, but we can easily draw ourselves a small sketch just to show what this graph is actually going to look like. And I'll draw one in this little small space that I have here. Okay, so your x-axis and y-axis. So what do we know? Well, we know the graph will pass over x equals 1, and we know it will pass over x equals minus a half, which is over here somewhere, and also x equals minus 3, which let's just say is over here somewhere. What else do we know? We know the y-intercept is at minus 3, so this term over here represents your y-intercept. So let's say that's over here somewhere. So this is minus 3, and since the polynomial has a positive coefficient of x cubed, we know it will have to start somewhere around here, and it will make its way up, and it will come down, and then it will come back up again over here. Okay, so we're just going to draw ourselves a small sketch of this cubic. Okay, so it should look something similar to the following. Okay, so this is what your cubic polynomial will look like. Well, I hope that's helped. So this was a lesson all to do with factor theorem, factorising a cubic polynomial, solving a cubic equation, understanding the factor theorem and how we can use it to answer a range of different types of questions. So hopefully you've got a better understanding in tackling these types of questions. If you haven't yet subscribed to the channel, please ensure you do subscribe so that you can receive further updates. If you liked the video, please give it a thumbs up, and I'll see you again in the next tutorial.